right, number one, what's the domain? The question is simply, what is the domain? Please don't get confused, don't make it hard. It says, what's the domain? That's kind of the same thing as saying, where are the vertical asymptotes? Because when we talk about the domain, what am I worried about? Having a 0 in the denominator. So whatever happens, x squared minus 2 cannot be 0, right? So x squared cannot be 2, and x cannot be what? Plus or minus the square root of 2. So what's your domain? Everything except positive and negative square root of 2. Number 2 says find the zeros. Now this is a necessary skill, even if, you know, the problem, this may be the numerator of something you're graphing. You need to be able to solve something like this. So what's our strategy? If we were to find the zeros, what are we going to do with this? PRRs. It does not group, so we're going to do the PRRs. Anybody happen to see one right off the top of what? -1. Good. It helps when we have a group, goes quicker. Yep, good job. So we know that one of our answers is -1. It says find the roots. That means find the zeros, find the answers to the questions. Now what do I do next? Yeah, this guy is now 2x squared minus 3x minus 20. And with any luck, that will factor, right? But of course, if it's a quadratic and you don't want to factor it, you look at that and say, oh, those numbers are kind of big, I don't want to do that. You can always use the quadratic formula. This will be on the no calculator part of the test, though, so you'll want to make sure the numbers aren't too huge. If you're using the quadratic formula. Anybody see it? 4 and 5. Yeah, there you go, 4 and 5. Yep, good. So I mean -4 plus 5, because that's a -8 and a positive 5. Good. So what are the other two roots then? If these are the other factors, the other two roots are -5/2 and +4. There's the one you guessed, and then there are the two that come out of the quadratic formula. B is exactly the same idea. Only there's going to be more of them. We don't have any choices here, just the twos and the ones. What do you think? Does 1 work? No. Does -1 work? Okay. So -1 worked. What's left? X cubed. Uh-oh. Are you paying attention here? Take a look at that right there. Now, could we repeat? Absolutely. But that factors by grouping. So when they factor by grouping, feel free to do that. It's usually a time saver. But of course, if you don't notice that it factors by grouping, that's fine. You're just going to repeat the process here. You're going to guess again. I'm going to go ahead and group it. And when I group those last two, all I can take out is a 1. But that's okay because I'm just trying to match my parentheses, right? Patty? Yes. Can you put that away for me, please? a pencil out and write some of this down? Huh?
I really don't have a notebook.
You don't have the paper with you? Maybe a sheet of paper and just write them down?
Yeah, I do have to after this test.
Yeah, you can write it wherever you want. That'll work. Thank you, Maria. Okay, so my common factor is x minus 2, and I'm left with x squared plus 1 as my other factor. Everybody still with me? Uh-oh, now wait a minute. My job was to find the zeros, right? Okay, well I found 1 over here. So one of my roots was -1. That's the one I guessed. One of them is 2. And what's that going to give me? Plus or minus I, because x squared equals -1, so plus or minus I are my roots. Now, if this were a graphing problem, remember the zeros are the x-intercepts. But if this were a graphing problem, you would only have 2 dots on your number line, right? Because that's not plottable. It just means there's some other squiggly stuff going on in the picture. Okay, one more. See, we're solving. This one, this is the kind of problem that catches you off guard if you're not alert. Do not use the quadratic formula. There was one like this on your test, your last test, and some of you used the quadratic formula because you thought, oh, it kind of looks like a quadratic, but it's not, right? This is a cube. Your PRRs are 7 and 1, plus or minus 7 and 1. Looks like 1 works. So I'm going to go ahead and divide 1 out, but when I divide it, I'm very, very careful about including the missing power. Remember when we do synthetic division? The missing, anything that's missing has to be represented with a 0. So here we go. Good. So my job is to find the zeros. One of them is 1. Now, where are the other 2 going to come from? Which is x squared plus x plus 7. No way is that factoring, but it is a quadratic. This one is quadratic. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Underneath there, what have I got? -27. So my other 2 answers, okay, the square root of -27. First of all, the negative's going to mean an I, and 27 is 3 root 3. So we're going to have 3i root 3, yes indeed, Mallory, over 2. So there are, remember this was a cube to start with, there's 3 answers there. 2 of them are imaginary, 1 of them is real. So if you typed this in on your calculator and hit graph, it would cross the x-axis how many times? Once, right there. Now it'll have a squiggly in it because of these imaginary roots, but it's only going to cross the x-axis once. All right, that wasn't so bad. All right, number 3. We solved one of these I don't know, someday we did one of these, just recently. Do you remember what we do? We subtract 2. Everybody remember that? We're tempted to multiply. No. Get 0. With your inequalities, always get 0. All right, what do we do now? Get a common denominator. This is like 2 over 1. So our common denominator is going to be x minus 2. This one's good to go. This one needs an x minus 2 on the top and the bottom. So now I have one fraction. My numerator is my x plus 5. Then be careful here. minus 2x plus 4. And then I end up with what? Simplify your top. We've got what? Negative x plus 9. Now, you remember what you do at this point? You put some dots on the number line. You're going to have 2 of them, 2 dots on the number line. One of the dots is going to be a 2. When we start throwing in negatives, if you're confused by that, set it equal to 0 and figure out what it'll be. It looks like the other dot will be at 9. So one dot's at 2, one dot's at 9. Anything colored in? Just the 9. Now we'll pick a number. Any number except 2 or 9, so we can use 0. 0 is over here. 0 would give me negative 9/2. Is that the kind of answer that I was supposed to get? No, because what does greater than 0 mean? Positive. This is not positive. So that number didn't work. So this section doesn't work, which means this one will and this one won't. So my answer is everything between 2 and 9, including 9. Everybody good with that? All right, B. We're solving this, all right? What do you notice about it as you're writing it down on your paper? What do you notice about it? It groups. Now, if you didn't notice that, would you know to do PRRs? Because those are your 2 choices. You're either going to group it or you're going to do the PRRs. This one does group, so we'll get it done. Remember, when you factor out the -1, that becomes an x plus 3. Thank goodness, because we want that to match, right? Everybody keeping up here? That factors more, as you know. Now what? I got it all factored. Now what do I do? Now I'm going to draw my number line. And this time I'm going to have 3 dots. And they will all be open. And where will they be? -3, -1, and 1. Make sure you get them on there in the right order. Pick any number you want except those. So 0 will work. If I put 0 in, now remember, 0 is right here. This is the section I'm checking right here. If I put 0 in, I get 3 times 1 times -1. Is that the kind of answer that I needed? Yep. So where 0 is works. Doesn't work, doesn't work, does work. So my answer is everything from -infinity to -3, or everything from -1 to 1. Everybody good? You agree? All right, that wasn't too bad. All right, and C. Now, don't be confused by C. It's already half done for you because you've already got 0. Your goal in an inequality is to get 0. You've got it. It's already there. So it's not like the one I just erased where you have to subtract and get a common denominator and all that. That's already been done. So you are now ready to go straight to the number line and put 3 dots on there. How do I know there are 3 dots on there? There are 3 x's, and every x is going to get a dot. So where are the dots going to be for this problem? 1's going to be -2, 1's going to be 0, and 1's going to be -4. So I got to get them on there in order. There they are. There are my dots. -4 makes the top 0. -2 and 0 make the bottom 0. So that's where those dots came from. Any of them colored in?
-4.
The -4 is colored in. This is an or equal to problem. You're never going to color in any dots that come out of your denominator because those cannot be values. And for the first time in a long time, we're not going to be able to try 0. We're going to have to pick a different number because 0 is a dot. So doesn't matter what number you want to pick. 1. Okay, so we're checking out here. We're going to try 1. So 1 would give us 15 over 3 times 1. Right? Now, does that give us the kind of number that we want? No. So that means that area doesn't work, which means this one will, and this one will. So the answer to the problem is everything from -infinity to -4, or everything from -2 to 0. You okay with that?
Always an alternate.
Well, as long as there's no squares or anything weird in factoring. All right, find all asymptotes and intercepts of this. Find all asymptotes and intercepts of this. Okay, so let's do asymptotes first. Doesn't matter. We said we're going to have a vertical asymptote and we're going to have an end behavior asymptote. End behavior. Now in the old days, I said vertical and horizontal, but now we've graduated to the point where we know there's other end behavior asymptotes besides horizontal. Could it be horizontal in some problems? Yes. This one is not horizontal. And I know it's not because the top power is bigger than the bottom. So to find my end behavior asymptote, I'm going to do my division. And again, I know it's not going to come out to be 0, and I'm not even worried about that. What's my end behavior asymptote going to come out to be? Y equals x minus 5. Everybody hanging in there? Now what's my vertical asymptote?
-2.
X equals -2. Because vertical asymptotes are domain issues, that's what makes the denominator 0. All right, now I need my intercepts. I need my y-intercepts and my x-intercepts. And remember, y-intercepts are when x is 0, and x-intercepts are when y is 0. So what do I get if I plug 0 into that function right there? 5/2. So my y-intercept is 5/2. And intercepts are points, so we should get in the habit of writing them as ordered pairs. Now, if I set this thing equal to 0, in other words, let y be 0, then what happens to the denominator?
It goes away.
It goes away. So I'm basically solving this equation right here. If I'm looking for my x-intercepts, right? What kind of equation is that? Quadratic. Oh boy, it doesn't factor. What do? I use the quadratic formula. So x equals -b plus or minus the square root of b squared. Uh-oh, uh-oh, uh-oh. I'm going to stop right there and say there aren't any x-intercepts. This curve does not touch the x-axis. How do I know? What happened up here? I'm going to get an imaginary number. Now that does not mean there aren't any zeros. Whatever I get, if I finished that, would be the zeros. But the question didn't say find the zeros, it said find the intercepts. And the intercepts are plottable points, and that's not plottable. Got it? Okay, next, solve. Now this is an equation, an equals. So you can absolutely clear your fractions, and I would recommend that. Not that you have to. Is that a 10?
Yeah.
I can't even tell what it is, but we'll go with 10. You are allowed to do this any way that works for you. Personally, I am going to multiply everything by 2x minus 2. My common denominator is 2 and x minus 2. So I'm going to multiply all three pieces by that so that stuff cancels out. So here, 4x squared plus 2x equals here 20 minus, now this is where things can get tricky if you're not careful. This will be negative 5x plus 10. Everybody catch that? I'm subtracting 5x minus 10, so it's going to be negative 5x plus 10. What kind of an equation is that? Once again, it is quadratic, so I'll get it set equal to 0. Is that okay? Now, if it, I can either factor it, and I don't know if it factors or not. It does? Yeah, I'm taking a test. I don't have a ton of time. I'm not going to spend 10 minutes trying to figure that out. I'm going to jump in and do my quadratic formula. But are you the one trying to set a factor? How's it factor?
4x plus 15 and x minus 2.
Let's double check that real quick. 15 minus 8. Good job. Yep. So what am I supposed to be doing? Solving. So my answers are negative 15 fourths. Or 2. Beep, 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 beep. Here come the radar. What about 2? It can't be. We call 2 an excluded value. It's an extraneous root. It doesn't work in the original problem. Everybody catch that? Well, now that I called it to your attention, you need to be able to catch that on your own. Sometimes when you start these problems, it doesn't hurt to just over to the side, right from the very beginning, say, oh no, I don't have, zero's not excluded. I have an excluded value and it's 2. X can't be 2. All right, now sketch, list all discontinuities and intercepts. Discontinuities, remember, are any breaks in the picture. So think about the pictures that you've drawn. What are things that break up the picture? Holes. What else breaks the picture? Asymptotes. So when it says list all discontinuities and intercepts, we're listing asymptotes, intercepts, and holes. Those are the things we're listing. Okay, but it does say sketch. So we're going to go ahead and sketch this one. And since it says sketch, we are going to do what first? Always, always, always. What first?
Factor.
We're going to factor. So let's see, I can take a 2 out of the top. So my top is going to factor as x minus 3, x minus 1. And my bottom as x minus 3, x plus 3. Everybody with me? I'm going to have a hole. So it says list it, so my hole is going to be where X is 3. And my new problem, the one I'm going to use from here on, is right here. So I'm going to plug in 3, and I'm going to get 2 times 2 over 6. 4, 6. 2/3? So it says list all intercepts and discontinuities. So I have a removable discontinuity, a hole, at the point 3, 2/3. All right, what about asymptotes? Do I have a vertical asymptote? X equals -3, so I have a vertical asymptote at X equals -3. Everybody keeping up? I have a horizontal asymptote at Y equals 2. Did you notice right from the beginning that your powers matched? So your end behavior asymptote was going to be horizontal? Okay, do I have a y-intercept? Well, I don't know. Let's let x be 0. If x is 0, you're going to have -2/3. Do we have a y, or excuse me, an x-intercept? Where is it? 1. Okay, so we have now listed all of our discontinuities, the hole, the asymptotes. We've listed our intercepts. We have one x-intercept, one y-intercept. So now sketching it, hopefully is not an issue for you. Can you see it over here? And here? Now again, I didn't have any points over here, so I just used my common sense. But if you wanted to plot some, you know, put -4, -5, -6, plug them in, set up a little T-chart, and you can get that thing graphed. All right, now I want to ask you, it's not on there, but we're almost out of time. I want to ask you a couple questions here. So using this picture, this function, if I said, what's the limit as x approaches -3 from the negative side, what would you say? What's the limit as x approaches -3 from the negative side? What would you say? If you say positive infinity, you are correct, because here's -3, it's an asymptote. As we come at it from the left side, your pencil goes up. One more. What's the limit? Remember, the added time on, we're still in our time. Don't get excited. If I said find the limit as x approaches 1 of this function, I'll say 1 from the positive side. What would you say?
0.
0. Kids, what happens at 1? 1 is a point. And the limit value of a point is always just the y coordinate. Right? And that would be true if I said what's the limit as x approaches 3 from the positive side. The answer would still be 2/3. Open points work just like closed points in that regard. Okay? All right. Okay. So you're off and running. Keep in mind that, let's see, I see you again tomorrow. Awesome, 2 days in a row. And we will finish up reviewing and we have a test on Monday. Okay? All good.
Was the test tomorrow?
Didn't they email you the schedule?
No.
All right, here. Do you want it?
Late arrival and early.
I got it. Just tomorrow.
Oh, yeah.
You gotta take a picture of it. Anna,
Later,